So this is the first lecture of analytical dynamics. So basically today I will discuss some basic definitions. Okay. So first see the definition. So first see the definition of displacement. Okay. So what is displacement? It is the change of position of a moving point in a definite direction. Okay. Suppose a particle starts from the position A and it's go up to this position. Okay. So what is the displacement? So AB will be the displacement of the particle. Getting my point? Okay. So if a particle, suppose if a particle starts from the point A and comes to the point B in a time t along any path, it may be curved, then the displacement in time t, so this will be the displacement. So AB, that is the displacement. Okay, the displacement in time t, is the distance AB in the direction from A to B. Okay, so since it is a directed line segment, that is this displacement, that is a directed line segment AB. Okay, so we conclude that displacement, that is a vector quantity because it has a magnitude as well as direction. Okay, so the displacement has magnitude as well as direction. Okay, displacement. So the displacement has magnitude as well as direction. So it is a vector quantity. Okay, so what is the displacement? That is, it is the change of position. It is a change of position of a moving point in a definite direction. Clear? So next, what is velocity? It is very important. What is velocity? The rate of change of displacement with respect to time. The rate of change of displacement with respect to time, it's called velocity. The rate of change of displacement with respect to time is called velocity. Suppose as be the displacement of the particle from a fixed point on a straight line in at time t, then velocity, so velocity v will be ds dt. Okay, so note this point. So velocity will be ds dt. What is velocity? So velocity will be ds dt. Yes, s is the displacement of the particle at time t. What is s here? S is the displacement of the particle at time t. So velocity আমরা কি করে ক্যালকুলেট করব? We calculate, just differentiate with respect to time because it is the rate of change of displacement. Here, what is s? Basically, s is the displacement. S is the displacement of the particle at time t. So velocity will be ds dt. Note this point. So this is the expression for velocity. V will be ds dt. What is s? S is the displacement of the particle. Getting my point? Okay. So next, what is acceleration? The acceleration is the rate of increase of velocity with respect to time. That means, how to calculate acceleration? Acceleration is denoted by f. Velocity, the rate of change of velocity with respect to time. That means acceleration will be dv dt. Getting my point? What is v? V is the velocity. What is v? V is the velocity. So what will be acceleration? So acceleration will be dv dt. Getting my point? So acceleration will be dv dt. Right? Now just see, what is v? Basically, v is ds dt. Yes or no? Yes. V is ds dt. Right? So this can be also written in the form d2s dt2. কেন দেখো ডেরিভেটিভ করো dv dt. So this will be d2s dt2. Clear? So f, that is acceleration, f will be dv dt, or it can be expressed as d2s dt2. Clear? Thick. Now just see, we know that, so f is dv dt, so this can be also written in the form dv ds into ds dt, right? So ds dt, so that is velocity, ds dt, that is velocity, right? So ds dt, that is velocity, that means v dv dt. Clear? So acceleration f, so this can be written as either dv dt or d2s dt2 or v dv ds or v dv ds. Clear? So f is dv dt, so this can be written as dv ds into ds dt. So ds dt, that is velocity, ds dt, that is velocity, that is v, so v dv ds. So what are the form of acceleration? That means the acceleration f will be, so that is the acceleration f will be dv dt, right? Or dt2 or v dv ds. Getting my point? So this is the expression for acceleration. That is what we get. We conclude that the velocity, that is v, will be ds dt. What is s? S is the displacement of the particle at time t. What is acceleration? That is the rate of change with respect, the rate of change of velocity with respect to time is called acceleration. That is, f will be dv dt or d2s dt2 or v dv ds. So this is the expression for acceleration, right? Clear? So now we discuss some example based on this. Okay, so just see this problem. For a particle moving in a straight line in the same direction, the distance x feet from a fixed point on the line described in time t seconds is given by, that is here displacement. Displacement ki dene ko x de. Here we denote the displacement, that is x, is given by x is equal to, note this, x is equal to 3t square plus 2t plus 4. So what is given here? Displacement, that is x is equal to 3t square plus 2t plus 4. So this is given. We have to find the distance. X is the displacement. We have to find the distance, the velocity, and the acceleration of the particle at the end of 5 seconds, right? So here we have to calculate the distance of the particle after time t, after time 5 seconds. Also we have to calculate velocity and we have to calculate acceleration, right? So we have to calculate distance, velocity, and acceleration after 5 seconds, at the end of 5 seconds. Okay, clear? So what is given here? We have, note this, here we have x is equal to this. Okay, so therefore velocity v, just displacement ke t respect to differentiate, you get velocity, right? ds dt, what is s? S is the displacement. Here x is the displacement, that is dx dt. So this will be the velocity. So v will be, that is v is dx dt. Clear? So this equal, now just simple differentiate. So x is this, so dx dt, that is 60 plus 2, right? And what is acceleration? Velocity ke t respect to differentiate karo, that we get acceleration, right? and F is equal to, that is acceleration, and F is equal to dv dt, right? ভেলোসিটি কে যখন টি এর রেসপেক্টে ডিফারেন্সিয়েট করব, দ্যাট ইজ অ্যাসেলারেশন, ঠিক? সো dvd, v is 60 plus 2, so now differentiate this, so this will be 6. Okay, so what are the form of acceleration? That is dv dt or d2s dt2. For this problem here, x is the displacement, so how to calculate acceleration? So d2x dt2, 2 times differentiation, right? So this is the velocity and this is the acceleration. Here we have to calculate the distance after the end of 5 seconds. Okay, ठीक? At the end of 5 seconds, at the end of 5 seconds, t, that is t is 5 here, right? So number 1 we have to calculate, and hence number 1, first we have to calculate the distance. So the distance of the particle, distance of the particle, that is x, right? So this equal to 3t square, t is 5, so 3 into 5 square plus 2t, t is 5 plus 4. Take, so if you simplify this, you get 80. So the displacement will be 80 feet. I think up to this, if we calculate this, you get 89. Okay, so 89 feet. Clear? So next we have to calculate the velocity. So what is velocity? Velocity will be 60 plus 2. So number 2, velocity of the particle. Number 2, velocity of the particle. So this will be 60 plus 2, t is 5, so 6 into 5 plus 2, right? So 30 plus 2, that means 32 feet per second. Clear? Also we have to calculate acceleration of the particle. So what is acceleration? Acceleration is F is dv dt, so we get F is 6. So the acceleration of the particle, number 3, acceleration of the particle so this will be 6 feet per second square. Okay, so clearly we see that, just see here the acceleration is constant, right? We get F is 6, so we conclude that the particle moves with constant acceleration 6 feet per second square, right? So clearly we conclude that clearly the particle moves with constant acceleration, acceleration 6 feet per second square. Okay, so this is the answer. I think clear. So how to calculate velocity? So velocity will be ds dt. What is s? S is the displacement. So for this problem, here the displacement is x. So velocity v will be dx dt, right? What is acceleration? Acceleration, that is f. F will be dv dt, or it can be written as d2s dt2. Here x is the displacement. So d2x dt2. Okay, clear, I think, right? Okay, so let us consider next example. Just see this problem. Just see this problem. What is given here? Here it is given that the velocity v of a particle moving along a straight line is given by v square is equal to a h square plus b. What is s? Here s is the distance traveled from a fixed point on a line. That means s is the displacement of the particle. It is given that s is the velocity displacement of the particle. A and b are constant. Prove that the acceleration varies as the distance from the fixed point on the line. Okay, so here basically we have to show the acceleration that varies as the distance from the fixed point on the line. So what do we prove? Acceleration, that is f varies as s. We have to prove this. Basically we have to show that f varies as s. F is the, just see, acceleration, that is f varies as the distance from the fixed point on the line. The distance from the fixed point on the line, that is displacement. So we have to show f varies as s. Clear, right? Okay, so what is given here? Here it is given that we have v square, that is velocity expression. We have v square is equal to as square plus b. We have to calculate, we have to show f varies as s, right? So now differentiate with respect to s. Okay, so differentiating with respect to s, we get, so 2v dv ds, so this equal to as. Now just recall this point. Acceleration, that is f, will be either dv dt or d2s dt2 or v dv ds. So this is the expression for acceleration. This is the expression for acceleration, right? Yes or no? Yes, either f will be dv dt or d2s or v dv ds. Okay, so here we just see differentiate with respect to s, we get 2v dv ds is equal to s. So this implies that v dv ds, so this equal to s. So v dv ds, that is acceleration, right? V dv ds, that is acceleration, right? So this implies that acceleration is as, right? So ultimately what we prove? Acceleration, that is f is equal to as. So what we proved here? We proved that f is equal to as. A is the, what is a is constant. So we conclude that acceleration varies as the distance from the fixed point on the line. That means f varies as s. Okay, so we conclude that hence we conclude that acceleration, that is f varies as s. Clear? It's very easy. Okay, I think no doubts. Acceleration is s. What is it? Where s is the distance of the particle from a fixed point on the line. So we proved that f varies as s. Clear? Okay. So next problem, just see this problem. So these are the basic problem. Okay. So just see this problem. A particle moves in a straight line according to the law v square is equal to 4a into x sin x plus cos x, where v is the velocity of the particle at a distance x from a fixed point. We have to find its acceleration. Here we have to calculate the acceleration. Basically here displacement, so this is x, right? So what is given? We have to calculate acceleration. So f either dv dt, right, or d2s. Here x is the acceleration, x is the displacement, so d2x dt2, or v dv ds. Here x is the displacement, so dv dx. So we have to calculate either this form or this form, right? So this is the expression for acceleration. Just see what is given here. We have v square is equal to 4a into x sin x plus cos x, right? So now just see if we calculate v dv dx, then we conclude that the acceleration, we can calculate the acceleration, right? So now differentiating both sides with respect to x. Okay, so differentiating both sides with respect to x, we get that is 2v dv dx. So this equal to 4a. Now simply differentiate. So x cos x, right, plus x fixed, so that is plus sin x, right? So derivative of cos x, that is minus sin x. So plus sin x minus sin x cancel. That means 4a x cos x. So this implies 2v dv dx, right? So this implies that v dv dx, so this is 2ax cos x. So v dv dx, so that is the acceleration, right? Hence acceleration, that means v dv dx. So acceleration we get 2ax cos x. So I think clear, no doubts. Okay, so this is the acceleration of the particle, right? Clear? So we find the acceleration of the particle, that is f will be 2ax cos x. Okay, ठीक? Okay, so let us consider next problem. Just see this problem. The law of motion of a body moving along a straight line is x is equal to 1 by 2 vt. What is x? What is x here? X being the distance from a fixed point on the line at time t. That is, here x is the displacement of the particle, right? X is the displacement of the particle. V is the velocity. Prove that it moves with a constant acceleration. Okay, so basically we have to show the acceleration f is constant. right? What we prove here? We prove that f is constant, right? So what is given here? Here it is given that here what is given here? The displacement x is equal to 1 by 2 vt. So this is given. Okay, so first we are going to calculate velocity. Velocity can be TSP differentiate karo, you get the acceleration, right? V f is dv dt. So first we are going to calculate v, that is velocity of the particle. Okay, so here x is the displacement, so velocity v will be dx dt. X is the displacement, so v will be dx dt, no doubts. X is the displacement के जो तुम्हें t differentiate करो, you get the velocity of the particle. Here x is the displacement of the particle, so v will be dx dt. Okay, so now simple expression of x is equal to 1 by 2 vt. So now differentiating with respect to t. Okay, so differentiating with respect to t, we get, so dx dt, so this will be 1 by 2, right? 1 by 2v plus 1 by 2 t is constant dv dt. ठीक? Now dv dt, that is dv dt, that is acceleration, that is f, right? What is f? F is the acceleration, that is dv dt. So dx dt, that is the velocity, right? So this implies that v is equal to 1 by 2v plus 1 by 2 into t dv dt, that is f. Okay, so since v is dx dt and acceleration and f is dv dt, no doubts, right? So v minus 1 by 2v, so that will be v. So ultimately what we get? So this implies that v minus 1 by 2, that is 1 by 2 v is equal to 1 by 2 tf. So 1 by 2 cancel. So ultimately what we get? So this implies that v is equal to tf. So this is the velocity expression, v is tf. Okay, right? So now we have to calculate acceleration. So if we differentiate with respect to t, that is dv dt, so this is the acceleration, right? So ultimately what we get? That is, so we get, that is v will be t into f. So this is the velocity expression. Velocity के यदि t respect to differentiate करो, we get the acceleration, right? So now differentiating with respect to t. Okay, so again differentiating with respect to t, again differentiating with respect to t, we get, so what we get? dv dt. So this will be f, t respect differentiate, so f, so right, so f is fixed, so that means, okay, so next t df dt. So dv dt, that is acceleration, so f is equal to f plus t df dt, right? Since f will be dv dt, since acceleration, that is dv dt, Getting my point? Acceleration, that is dv dt. So ultimately, what we get? So ff cancel. That means t. So this implies that t into df dt is equal to 0. So from this, we conclude that either t is equal to 0, right? T is equal to, that means it is start from the initial, that is, which is starting point. T is equal to 0. That means the particle is at the initial position, right? So therefore, either t is equal to 0 or df dt 0. So df dt is equal to 0. Just see, df dt is equal to 0. That means এটা integration করো, so f, so that is constant, right? So df dt is 0. That means if we integrate this, we get f. So if we integrate this, we get constant. Yes or no? So we conclude that the acceleration is constant. That is, we conclude that the particle moves with a constant acceleration. Okay, so therefore either t is equal to 0, that means which is the starting point, which is the starting point, right? Or df dt is equal to 0, or df dt is equal to, so df dt is equal to 0. What does it mean? That means f is constant, right? Which shows that f is constant, right? Df dt is equal to 0. So if we integrate this, we get f is constant, right? So we prove that the particle moves with a constant acceleration. Hence the particle moves with constant acceleration. Clear? ঠিক আছে? It's very easy problem. Okay, ঠিক? Okay, so let us consider next example. Just see this problem. What is given here? For a particle moving in a straight line, the distance is from a fixed point on the line described at any time t is given by s is equal to a cos nt plus b sin nt. That means here the displacement of the particle is given by a cos nt plus b sin nt. Okay, where a and b are constant, so that the acceleration of the particle is negative. Acceleration of the particle is negative and is proportional to s. That means f varies as s. We have to show this, and the acceleration, that is a negative quantity. Okay, so what is given? s displacement দেওয়া আছে, তাহলে velocity আমরা কি করে পাবো? That is simply differentiate with respect to time, with respect to t, that is ds dt. So this is the velocity. And what is the acceleration? Acceleration will be d2s dt2, right? Here s is the displacement, so velocity v will be ds dt. So this is the velocity, and f will be d2s. So this is the acceleration and this is the velocity. So velocity will be ds dt, and acceleration, that is f, will be d2s dt2. We have to calculate acceleration, right? So আমি কি করব, এটা just 2 times differentiate করব with respect to t. That is, we have to differentiate with respect to t 2 times we get the acceleration of the particle. Displacement কে যখন তুমি t এর স্কয়ার ডিফারেন্সিয়েট করবে we get velocity. Velocity কে আবার t এর স্কয়ার ডিফারেন্সিয়েট করো you get acceleration. That means displacement কে 2 times differentiate করো you get the acceleration, right? Okay, so what is given here? Here it is given that we have the displacement, we have s is equal to a cos nt, a cos nt plus b sin nt, right? So differentiate with respect to differentiating with respect to t we get, so what we get? Just simple differentiate. So ds dt, so differentiate, that is minus a n sin nt, right, plus b n cos nt. So this is the velocity expression. Now we have to calculate acceleration. So again differentiating, right? Okay, so again differentiating with respect to t we get, so d2s dt2, so this will be minus a n square cos nt, right? So differentiate this, that is minus n sin nt, so that is minus b n square sin nt. Is it clear? So now just taking minus n square common, okay, so this implies that d2s dt2, so this is the acceleration, right? So this is basically f, so this is taking minus n square common, so what we get? A cos nt, a cos nt plus b sin nt, plus b sin nt. So a cos nt plus b sin nt, that is s, that is minus n square s. So d2s dt, that is acceleration. You see, f acceleration is the negative quantity, right? F will be minus n square s. F will be minus n square s. What is n? Where n is a constant. So this shows that the acceleration is negative and it is proportional to s. N is the constant, so n is constant, that means f varies as s, right? Okay, so where n is constant, so ultimately what we see, that is the acceleration is negative and is proportional to s. So this shows that acceleration is negative and is proportional to s. F is equal to minus n square s, so we see that the acceleration is negative and is proportional to s, right? Clear? Okay, so let us consider next problem. Just see this problem. If a particle, just read this problem very carefully. If a particle moves in a straight line according to the law x is equal to a sin mu t plus b, that is here the displacement of the particle is given by this. This is a displacement. We have to prove that v square is equal to a square minus x square into mu square. V is the velocity and x is the distance traversed in time t. That means here x is the displacement of the particle. So basically here we have to prove that v square is equal to a square minus x square into mu square. So this is our target. Okay, so we have to prove that v square is equal to a square minus x square. We have to prove that v square is equal to a square minus x square into mu square. That is velocity expression. Velocity v will be dx dt. X is the displacement. That means velocity v will be dx dt. So we have to calculate dx dt basically, right? Okay, so what is given here? It is given that we have x is equal to a sine mu t plus b, right? So this implies that sine mu t plus b, so this is x by a. Okay, so what is velocity? V will be dx dt. Just simply differentiate. Okay, so therefore v will be, therefore v is dx dt. So x के तुम्हें t respect differentiate करो. Okay, clear? So that means just see, this is x. Now just simply differentiate with respect to t. That means a cos mu t plus b. Again we have to differentiate, that is simply mu into mu, right? Okay, so ultimately what we get? A mu. So ultimately what we get? So this implies that v is equal to a mu cos mu t plus b. Okay, we have to calculate v square. We have to prove v square is a square minus x square into mu square. So v square is equal to, so therefore v square is equal to a square mu square, right, cos square mu t plus b, right? So this equal to a square mu square cos square theta plus sin square theta is 1. That means cos square theta, so this is 1 minus sin square theta. So 1 minus sin square mu t plus b. So this equal to a square mu square into 1 sin mu t plus b, that is x by a, right? So sin square mu t plus b, that means x square by a square. So this equal to a square mu square into a square minus x square divided by a square, right? So this implies v square is this, so this implies v square is cancel, that is mu square into a square minus x square. So this is the velocity expression. That is v square is equal to mu square into a square minus x square. Clear? It's very easy problem, right? Okay. So let us consider next example. Just see this problem. It is a very, very important example. It is a very, very important example. Okay. So just see, a particle moves along a straight line according to the law s square is equal to what is given here. We have what is given. We have s square is equal to 6t square plus 4t plus 3. Prove that the acceleration varies as s to the power minus 3. That is, we have to prove f varies as s to the power minus 3. Okay, that means f varies as 1 by x cube. We have to prove this. ঠিক, তাহলে আমি যদি প্রুভ করতে পারি f is equal to something constant into 1 by x cube. If we prove that f is equal to something constant into 1 by x cube, then we can conclude that f varies as s to the power minus 3. So basically we have to calculate acceleration f, that is d2s dt2, right? Acceleration x, here s is the displacement of the particle, so acceleration, so f will be d2s dt2, right? So f will be d2s dt2. Getting my point? Clear? That means हम s के 2 times differentiate, we differentiate s 2 times. ठीक है? Okay, so therefore just differentiate with respect to t, so therefore 2s ds dt, so that means so 12t plus 4. Differentiating with respect to t, so what we get? 2s ds dt, so this is equal to 12t plus 4, right? So this implies that now differentiate dividing both sides by 2, so that means s ds dt, that is 60 plus 2. Okay, clear? What is f? F is d2s dt2, right? So this implies that ds dt, that is 60 plus 2 divided by s. Clear? So now again differentiating with respect to t, so therefore d2s dt2, so this equal to again differentiating with respect to t. Okay, ঠিক আছে? So what do we get? Just see denominator is square, right? That means s square, so s differentiate with respect to t, so 60 plus 2, that means 6, right? Clear? Minus এবার উপরটা fixed, that is 60 plus 2 fixed, s কে আমি differentiate করব, that is ds dt, simply differentiating with respect to t. Okay, so what is ds dt? Just see, ds dt is 60 plus 2 divided by s, right? So this equal to 6s minus 60 plus 2 ds dt, that is 60 plus 2 divided by s, whole divided by s square, right? Clear? So 60 plus 2 into 60 plus 2, that is 60 plus 2 square divided by s. That means ultimately s will be the LCM, right? So that means 6s square minus 60 plus 2 square divided by s cube. Is it clear? Just multiply koro, 60 plus 2 into 60 plus 2 divided by s, that is 60 plus 2 whole square by s. LCM ki hobe? S, that is 6s square minus 60 plus 2 whole square by s. That means s cube. Clear? Okay, I think up to this no doubts. Now it is given that s square is equal to 60 square plus 40 plus 3, so this equal to 6 into 60 square plus 40 plus 3, right, minus 60 plus 2 square. So 60 plus 2 square, just a plus b square formula apply karo, that is 36 t square plus 24t plus 4, right? Divided by s cube. So 36t square minus 36t square cancel, plus 24t minus 24t cancel, plus 12 minus 4. So 12, 18 minus 4, that is 14. So 14 by s cube. So we prove that d2s dt2, that means f is equal to 14 by s cube. So 14 is constant, so we conclude that therefore f varies as 1 by s cube, that means s to the power minus 3. Clear? So proved. We proved that the acceleration, that is f, varies as 1 by s cube. Clear? 14 is constant, so f varies as 14 by s cube, that means f varies as 1 by x cube. So it is a very, very important example. Similar problem. You can solve this problem. So this is your assignment. Same problem. A particle moves along a straight line according to the law s square is equal to at square plus 2bt plus c. এখানে constant গুলো হচ্ছে 6 4, just constant গুলো চেঞ্জ করে দিয়েছি, just at square plus 2bt plus c. Okay, prove that the acceleration varies as s to the power minus. Same problem, at square plus 2bt plus c, but here it is given 6t square plus 4t plus 3. Same bhabe problem solve korbe. So this is your assignment. Okay, clear? So আজকে আমি ফান্ডামেন্টাল ডেফিনেশনস, রাইট, ফান্ডামেন্টাল ডেফিনেশনস গুলো ডিসকাস করে দিয়েছি এবং এর রিলেটেড প্রবলেম গুলো ডিসকাস করে দিয়েছি। ওকে, all problems are very, very important. Okay, so I think clear. So thank you so much. Bye.